January morning, 1943. Somewhere north of Saint-Nazaire, in the rolling fields of occupied France, a thin mist hung low over the hedgerows. Frost clung to the edges of abandoned farm carts and the shattered timbers of a barn roof that had taken the brunt of an air raid weeks before. Out of that quiet, the sound of a distant engine coughed and died, followed by a grinding metal shriek that rolled across the valley like thunder. When the echo faded, 3 Luftwaffe ground personnel from a maintenance detachment near the village of Guenrouët were already climbing into their truck. They had been told that an amerikanischer viermotoriger bomber, an American 4-engined bomber, had come down intact somewhere west of the river Isac. Orders were simple: reach it before the locals or the resistance did. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra, special for you. The men expected twisted wreckage, perhaps a few scorched pieces to be collected for scrap and intelligence. They did not expect to find a machine that looked as though it had crash-landed from another age of industry, enormous, symmetrical, and unnervingly intact, its olive-drab skin only torn by the furrows of its emergency landing. The nose art still visible under the mud read in white block letters, "Lucky Lass." When Feldwebel Otto Menzel climbed the ladder into the cockpit, his first reaction was not triumph, but disbelief. Every surface instrument panel, overhead console, sidewall was crowded with switches, dials, and labelling in English. The smell of burned hydraulic fluid mixed with coffee and cordite. Menzel's hand brushed against the twin triggers mounted at the co-pilot's station, and he muttered to his comrade, "Verdammt, Sie haben hier Maschinengewehre überall." Damn it, they have machine guns everywhere. Within the next hour, as more Luftwaffe officers arrived from the nearby Le Bourget intelligence section, the men began counting. 1 gun at the nose, twin mounts in the top turret, twin waist positions, twin ball turret guns, twin tail guns, and 2 more in cheek blisters, 13 heavy Browning 50 caliber machine guns in total. For German airmen raised on the doctrine that bombers were lumbering victims to be shredded by cannon fire, it was a moment of collective re-evaluation. The Fliegende Festung, the flying fortress, was no metaphor. It was an engineering philosophy made steel. In the winter of 1942-43, Luftwaffe confidence in its fighter arm remained largely unshaken. The Jagdwaffe's aces had written a gospel of aerial superiority, one defined by the nimble Messerschmitt Bf 109 and the brutish power of the Focke-Wulf 190. They believed, with some justification, that any enemy bomber entering German-held airspace did so at its peril. Propaganda from Der Adler and the Wehrmachtbericht reinforced this belief. American bombers were said to rely on outdated defensive thinking, heavy armor, multiple gun stations, and slow formation flying tactics that modern German fighters had already mastered how to dismantle. The logic was simple. A bomber could never carry enough guns to defend against a coordinated fighter attack. That logic held until the first intact B-17 seconds began appearing in European skies in meaningful numbers during late 1942. From the air, they seemed cumbersome, flying in disciplined boxes that made tempting targets. But from the ground, especially when one lay intact before you, the illusion of vulnerability began to crumble. The Germans who surrounded Lucky Lass that morning did not yet know the scope of American production. They could not imagine that factories in Seattle, Long Beach, and Cheyenne were turning out 1 B-17 every hour, with thousands more on order. Nor could they yet comprehend that the same industrial philosophy that had given this bomber its 13 machine guns had also given America the means to replace it effortlessly. To the Luftwaffe officers on scene, the aircraft represented a contradiction, a fortress that had somehow taken to the air, an artifact of mass production built with the precision of a watch. The German mind, trained through decades of artisanal engineering, struggled to reconcile that idea. As engineers from the Luftwaffe Technisches Amt began documenting the wreck, they discovered evidence of an entirely foreign approach to manufacturing. Rivets were uniform to within fractions of a millimeter. Control cables were color-coded. Electrical connectors were standardized with stamped numbers matching maintenance manuals. This was not the work of craftsmen in overalls. This was the work of an industrial system operating at a scale Germany had never achieved. In Berlin, Albert Speer's Ministry of Armaments and War Production had only recently begun centralizing aircraft manufacture under his rationalization programs. Yet, even Speer's reforms, which attempted to standardize parts across Messerschmitt and Junkers factories, were hampered by the decentralized guild culture of German industry. Each plant still insisted on its own gauges, its own jigs, its own tolerances. The B-17 inches that French field, by contrast, was the physical embodiment of interchangeability. The American belief was that complexity should exist in design, not in assembly. Once perfected, the process could be repeated by semi-skilled workers in shifts, each part fitting any other bomber without modification. To men like Menzel, who had spent nights filing by hand the shims for a Junkers Ju-88's engine mounts, the realization was almost offensive. How could an aircraft built by assembly line workers in a democratic factory withstand combat better than one crafted by Germany's finest engineers? Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. The German technical officers carefully removed each machine gun for inspection. The Browning AN M250 caliber weapon weighed roughly 60 pounds and could fire 750 rounds per minute. Every position on the bomber had been designed with overlapping fields of fire so that any attacker approaching from any angle would face at least 2, sometimes 3, converging streams of bullets travelling at nearly 900 meters per second. The ammunition belts, each containing hundreds of rounds, were fed through flexible chutes that ran under armor plates and along the fuselage walls. Even more striking to the Germans was the ammunition itself, armor-piercing and incendiary rounds mixed deliberately to maximize damage against aircraft structures. In German service, the standard MG-15 and MG-81 had been replaced on some bombers with 20mm cannons for heavier punch, but these weapons were heavy, difficult to handle, and often suffered jamming. The Browning guns in the American Fortress, by comparison, operated with an almost clockwork reliability. The feed systems were simple, the mounts ergonomic, and the sight's optical ring and bead arrangements allowed rapid target acquisition even in turbulence. One Luftwaffe ordnance officer recorded in his field notes, later recovered by Allied forces in 1945. Each station is independent. There is no central power turret or hydraulic system as in our Heinkel designs. This allows for continued operation even after damage. Ingenious and wasteful at the same time, typical of the Americans. He did not yet understand that this wastefulness was deliberate. American doctrine accepted redundancy as the price of survivability. If one gunner or one system failed, another could compensate. Back at Rechlin, the Luftwaffe's central test center near Lake Müritz, word of the captured bomber spread rapidly. The facility had already evaluated a handful of Allied aircraft, including a P-38 Lightning and a B-24 Liberator wreck, but none so intact as this. Plans were made to transport the B-17 by rail once temporary repairs could be completed. In the meantime, Luftwaffe propaganda officers photographed the site for internal briefings. One series of images shows German officers standing beside the bomber's waist positions, the guns elevated as if still defending the skies above Bremen. In some of the photographs, curious French civilians look on from behind barbed wire, unaware that they are witnessing a secret now deemed of Reichsweite Bedeutung national importance. Among those who examined the machine was Hauptmann Ernst Kuhn, a veteran pilot of the Battle of Britain. Kuhn had fought in the days when single-seat Messerschmitts faced Royal Air Force Spitfires over the Channel. To him, aerial combat was an art of maneuver and precision gunnery, of men testing reflexes and nerve. Standing inside the fuselage of the captured bomber, surrounded by ammunition boxes and oxygen bottles, Kuhn felt something different, an impersonal scale of warfare that dwarfed the individual. He later told a colleague, according to post-war interviews compiled by historian Manfred Boehme, "In 1940, we fought other pilots. In 1943, we were fighting factories." The discovery of 13 machine guns on a single bomber raised urgent questions at Luftwaffe headquarters. Intelligence officers at the Forschungsamt in Berlin had previously estimated that American heavy bombers carried between 6 and 8 guns. Their assumptions now appeared dangerously obsolete. If each B-17 could defend itself with such firepower, and if hundreds flew in formation, the defensive perimeter of a bomber stream might become virtually impenetrable. Mathematically, the effect was staggering. A formation of 21 B-17 seconds could theoretically bring to bear more than 200 heavy machine guns in overlapping arcs. Even allowing for limited firing angles and ammunition expenditure, the density of fire created lethal zones extending hundreds of meters outward. German fighter tactics developed during earlier campaigns relied on frontal or rear assaults in compact rotter or swarm formations. Those tactics suddenly seemed suicidal. Reports from the Jagdgeschwader 26 and Jagdgeschwader 2, units that had engaged American bombers over the Channel, already hinted at rising losses. Pilots described approaching the formation only to see tracers forming a lattice of light so dense that it seemed solid. The men who would later test fly the captured B-17 at Rechlin wanted to understand how that lattice was created and whether it could be broken. While technicians catalogued every weapon and instrument, the psychological impact of the discovery spread quietly through Luftwaffe ranks. Many fighter pilots still clung to the belief that courage and skill could overcome industrial mass. They were men raised on the myth of the Einzelkämpfer, the lone warrior, an ideal immortalized by the aces of the Great War. But standing before the flying fortress, even the most romantic could see that war had changed. Here was an aircraft that turned the sky itself into an assembly line of destruction, where gunners replaced craftsmen and bullets replaced chivalry. Each trigger pull represented not an act of marksmanship, but the culmination of an economy operating thousands of miles away. For the German officers cataloguing Lucky Lass, that realization was quietly devastating. At Oberkommando der Luftwaffe in Berlin, the captured bomber's data was compiled into a technical dossier. The report, Bericht über den amerikanischen viermotorigen Bomber B-17F, circulated among senior staff in April 1943. It summarized construction methods, armament, and performance characteristics derived from ground tests. One section, translated from the original German, read, "The defensive armament of the aircraft represents a new level of concentration. The 12 to 13 machine guns of caliber half-inch create multiple zones of fire covering nearly all approach angles. The coordination of these positions within bomber formations multiplies effectiveness far beyond the capacity of single aircraft defense. Counter-tactics must consider this collective fire envelope as the primary threat." This technical language masked a deeper anxiety, that the Luftwaffe was confronting not merely a new aircraft, but a new philosophy of warfare, one that Germany was ill-equipped to match. That anxiety would soon be tested in blood. Within weeks, the American 8th Air Force intensified its daylight bombing campaign against occupied Europe. From bases in East Anglia, streams of B-17 seconds lifted off at dawn, their 4 Wright Cyclone engines roaring in unison, each carrying thousands of pounds of high explosives. To German radar operators along the coast, these formations appeared as dense clusters of returns, the so-called bomber pulks. Fighter controllers scrambled interceptors in waves, guiding them toward the approaching armadas. Yet even the most experienced pilots now hesitated before diving into the defensive web. Reports from Jagdgeschwader 2 Richthofen describe attacks aborted mid-run because gunners' fire was so intense that cannon shells detonated prematurely in the crossfire. One pilot, Lieutenant Karl Kummerow, wrote in his log after surviving an assault on a B-17 formation over Rouen, "Their guns burn the sky. You cannot see where one ends and another begins. It is like flying into a wall of sparks." By the time the captured Lucky Lass finally reached Rechlin for flight testing in late March 1943, its reputation had already outpaced its reality. Engineers restored its engines using salvaged parts from downed American bombers. German markings were painted over the white stars, black crosses and a swastika on the tail transformed it from enemy to experiment. When test pilot Hauptmann Hans-Werner Lersch, one of the Luftwaffe's most experienced evaluators, took the controls for the first taxi run, he noted how balanced the aircraft felt even at low speed. His subsequent report confirmed what American crews had long claimed. The B-17 handled like a much smaller aircraft, its control surfaces responsive and stable. But what struck Lerche most was not the handling. It was the design philosophy evident in every switch and dial. Where German cockpits were compact and utilitarian, the American layout was generous, built for crew coordination rather than solitary mastery. The pilot's workload was distributed through systems autopilot, trim controls, intercoms that assumed collective operation. The airplane was not designed for a hero. It was designed for a team. As news of Lerche's successful test flight reached Berlin, some within the Luftwaffe hierarchy dismissed the captured bomber as an oddity, an over-armed curiosity unfit for maneuver warfare. Others, particularly within the technical staff, saw it as a warning. One memorandum from the Technisches Amt, dated April 17, 1943, concluded, "If the United States can produce such machines in great number, then the outcome of the air war will depend not on pilot skill but on the exhaustion of our resources." It was an insight too uncomfortable for many to accept. The German fighter arm would continue to fight bravely, but from that spring onward, its leaders would do so with a growing sense that the balance of power had shifted irreversibly, revealed not by a battle, but by a single captured bomber resting in a muddy French field. The first test flight of the captured American bomber at Rechlin took place on the 17th of March, 1943. The air was cold, the runways glazed with the remnants of winter frost. Engineers stood along the perimeter fence, cameras and notebooks in hand, waiting to record what no German pilot had yet experienced, the feeling of controlling a flying fortress. Hauptmann Hans-Werner Lerche climbed the access ladder wearing a standard Luftwaffe test suit, the same he had used for dozens of captured aircraft, British Spitfires, Soviet Yaks, even an American P-38 Lightning. Yet, as he settled into the left-hand seat of the B-17, he paused. The cockpit was not arranged like any he knew. There were two large control yokes instead of a single stick, and a bank of instrument clusters so extensive that no one pilot could monitor them alone. The design assumed cooperation, a concept foreign to the single-seat fighter pilot's world of solitary command. The four Wright R-1820 engines turned over reluctantly, coughing before settling into a deep, synchronized growl. As the aircraft accelerated down the runway, its bulk seemed to defy physics. But at 110 miles per hour, the weight lifted, and the fortress rose smoothly into the pale sky. Lerche's initial flight report, later found in Allied archives after the war, contained a line underlined twice. Unexpectedly, light on the controls. Comparable stability to the Heinkel 111, but greater structural stiffness. The aircraft behaves as though carved from a single piece of metal. For the German observers below, the sight of their test pilot circling overhead in an American bomber painted with black crosses was almost surreal. It was as if they were watching a captured ideology take flight. The technical examination that followed lasted weeks. Every system, hydraulic, electrical, and structural, was subjected to detailed evaluation. German engineers were astonished to find redundancies built into nearly every circuit. Dual hydraulic pumps ensured that a single hit would not disable the flaps or landing gear. Fuel tanks were self-sealing, layered with rubber and fabric that expanded when penetrated by bullets. Control cables were duplicated along separate paths, so that damage to one side of the fuselage would not render the aircraft uncontrollable. In German bombers, such as the Heinkel 111 or Dornier 217, such redundancies were rare. Weight was saved wherever possible. Armor was minimal. Production efficiency took precedence over crew protection. The American philosophy inverted this logic completely. Survivability was not an afterthought, it was the design's foundation. When engineers tested the B-17 structure under simulated flak damage, they found that the wing spars could absorb hits that would have sheared a Junkers bomber in half. The stressed skin aluminum alloy, combined with an internal truss arrangement, distributed loads so efficiently that even severe structural breaches left the aircraft flyable. Lerche recorded during one flight, "We shut down one engine deliberately and reduced power on a second. The machine maintained altitude at 2,000 meters with minor trim adjustment. This cannot be duplicated with any German four-engine type under test." The implications extended far beyond the laboratory. Luftwaffe intelligence analysts began recalculating interception probabilities. The new data showed that a typical fighter attack required at least 20 seconds of sustained fire to ensure the destruction of a single B-17, assuming the fighter could approach to within 200 meters without being hit. In practice, very few managed to close that distance. The discovery shook tactical planning. Up to that point, German fighters attacked from the rear, where bomber defenses were thought weakest. Now, analysis from Rechlin proved otherwise. The twin-tail guns, combined with overlapping top turret and waist gun coverage, created a cone of fire so dense that rear attacks became almost suicidal. As a result, the Luftwaffe experimented with frontal assaults. These required extraordinary nerve. Pilots had to dive head-on into the bomber formation, firing cannon bursts during a closure rate of more than 600 miles per hour, then break away seconds before collision. Even experienced aces admitted the psychological strain was intolerable. "You must aim not at the bomber," recalled Oberleutnant Hans Eckhard Bob, "but at the place where death will be a moment later." To improve effectiveness, engineers mounted heavy 20 and 30 mm cannons under the noses of Messerschmitts and Focke-Wulfs. The resulting aircraft could shatter a B-17 with a single hit if they could reach it. But the gunners' overlapping, 50 caliber fire often crippled the attacker long before it could deliver that fatal shot. Throughout the spring of 1943, Lerche and his team continued to fly the captured bomber, gradually expanding its flight envelope. They tested stall behavior, dive recovery, and defensive visibility. The data accumulated into a comprehensive report nearly 100 pages long, a technical masterpiece that few in the Luftwaffe's command structure fully read. The findings were stark. The American bomber was not just a machine, it was a system integrated into a vast industrial and tactical network. Its strength did not lie in speed or maneuverability, but in the collective doctrine of formation flying. When dozens of such bombers flew wingtip to wingtip, their defensive arcs interlocked, forming a geometric pattern of overlapping fire that no single German fighter could penetrate without extraordinary risk. The Rechlin analysts concluded, "Destruction of these formations will require concentrated attacks by large numbers of fighters using heavy cannon armament in frontal engagement." This recommendation gave birth to the Sturmstaffel unit's specialized groups of armored Focke-Wulf, 190 fighters, equipped with additional armor plating and 4 20mm cannons. Their mission was straightforward and lethal: break through the defensive curtain and obliterate the bombers at close range, even at the cost of their own survival. But reality soon overwhelmed doctrine. By the summer of 1943, American bombers were appearing deeper and deeper over the Reich. The Schweinfurt-Regensburg raids in August demonstrated both the power and the cost of the strategy. German fighters inflicted terrible losses, 60 bombers downed in a single day, yet hundreds more returned, and the factories replaced them within weeks. At Rechlin, engineers ran the numbers and realized the devastating truth. Even if the Luftwaffe destroyed 200 bombers every month, American industry would produce 400 to replace them. Each bomber lost carried 10 men, each German fighter lost carried 1. But the Luftwaffe could not replace its pilots as quickly as the Americans replaced machines. Hauptmann Lerche, reading these figures, wrote in his private notes, "We can win every dogfight and still lose the war. The fortress is not only the airplane, it is the country that built it." The psychological shift among Luftwaffe officers mirrored the technical revelations. Many had entered the war believing in qualitative superiority, the idea that a few skilled German pilots could overcome any quantitative disadvantage. This belief had roots in the interwar years, when the Treaty of Versailles had forced German aviation into secrecy and improvisation. The result was an aviation culture that prized ingenuity over mass. The B-17 shattered that illusion. It revealed a world in which quantity was a quality, a world where standardization, logistics, and teamwork replaced individual brilliance. When young Luftwaffe cadets toured the captured bomber during instructional briefings, instructors pointed out the crew coordination systems, interphone headsets, linking every station, oxygen distribution manifolds that kept all 10 men alive above 20,000 feet, and electrically heated flight suits powered through a central system. To the cadets, barely 20 years old, these details were astonishing. Their own fighters offered little more than a thin leather jacket against the cold. One recalled after the war, "It was like stepping into a factory that could fly. Everything was made so that anyone could do his task, even if he was tired or afraid. It was the opposite of how we fought." By late 1943, as the Luftwaffe bled pilots over Bremen, Hamburg, and Schweinfurt, the Rechlin test program had completed its mission. The captured bomber was now worn, its olive paint faded, but still operational. German engineers used it for comparison trials against the emerging Heinkel II-95 and the abortive Amerika bomber designs. But the fortress had already taught its greatest lesson, one that no new prototype could: unlearn. The age of artisanal war was ending. The fortress embodied a society capable of mobilizing millions of workers and engineers toward a single, standardized goal. The Luftwaffe, for all its skill, could not match that industrial democracy with its network of dispersed, under-resourced factories. The captured aircraft was eventually moved to a storage hangar near Rechlin's southern perimeter, where it remained until the final months of the war. In April 1945, as Soviet forces advanced through Mecklenburg, the bomber was destroyed on the ground to prevent capture, a final irony for a machine that had once been prized for the secrets it contained. In the post-war years, fragments of the Rechlin documentation surfaced in Allied intelligence archives. American analysts were fascinated to read German assessments of the very aircraft they had built. The reports confirmed what many American airmen had only guessed, that the Flying Fortress had not merely survived a German attack, it had fundamentally altered the way the enemy understood air power. For the Luftwaffe pilots who had first found the downed bomber in that French field, the memory lingered. A few survived the war and spoke about it decades later in interviews. 1. Former Feldwebel Otto Menzel described standing beneath the tail guns, staring into the twin barrels that had once spat fire at his comrades. "We were proud men," he said softly, "but that day we saw something bigger than pride. We saw what industry and imagination together could do. I think that was the moment I understood we could not win." The irony of the Flying Fortress lay not only in its firepower, but in its symbolism. The Germans who examined it believed they were studying a machine. In truth, they were witnessing an entire civilization expressed in aluminum and rivets. Every switch and gun mount represented the capacity of a free industrial society to coordinate complexity without collapsing under it. The fortress was not unbeatable. Thousands were shot down, yet its existence forced Germany to expend resources, pilots, and hope at an unsustainable rate. Each mission it survived eroded the myth of Luftwaffe invincibility. By 1944, when Jimmy Doolittle's new fighter doctrine unleashed the P-51 Mustangs across the Reich, the lessons learned from that first captured bomber became historical footnotes. But for the men who had stood in that muddy French field a year earlier, the shock of discovery had already foretold the outcome. The war in the air would not be decided by a single dogfight or by the courage of individuals. It would be decided by production lines, logistics, and the capacity to turn raw metal into organized firepower faster than the enemy could destroy it. The Flying Fortress had shown the Luftwaffe that truth long before Berlin burned, that the future of war belonged to the machines that could defend themselves, and to the societies capable of building them in thousands. When the guns finally fell silent in May 1945, Europe was a landscape of wreckage and memory. In hangars across Germany, Allied technical teams began a systematic search for anything that could reveal how the Luftwaffe had fought, flown, or learned. Among the crates of salvaged engines, jet prototypes, and radar components, investigators found a small bundle of folders stamped Erprobungsstelle Rechlin B-17E. Inside were charts, diagrams, and typewritten pages covered in the meticulous handwriting of German engineers. They were the same men who had once crawled through the wreckage of a downed American bomber in northern France. Now, their analysis, born in secrecy, had become a prize of the victors. The Rechlin reports fascinated Allied scientists. They revealed not only what the Germans had learned about the B-17, but how they had learned it through disciplined testing, structural measurement, and aerodynamic simulation. American and British officers at Operation Lusty, the code name for the Allied sweep of captured Luftwaffe technology, forwarded copies of the B-17 evaluation to Wright Field in Ohio, where U.S. Air Technical Intelligence was headquartered. To American analysts, the irony was striking. The Germans had studied the B-17 inches the hope of defeating it, yet their notes now helped the U.S. refine bomber design for the next generation, the B-29 Superfortress, and the coming jet-powered B-47 Stratojet. At Wright Field, engineers compared the Rechlin data with their own post-combat analyses. German measurements of vibration frequencies, wing flex stress, and armor distribution were remarkably accurate. One colonel remarked, "They reverse-engineered our aircraft better than we sometimes understood it ourselves." The lessons of redundancy, modular systems, and survivability that the Germans had admired were incorporated, almost subconsciously, into the logic of Cold War aviation. The idea that a complex machine must continue to function under damage became a cornerstone of American engineering from bombers to space capsules. Not every captured fortress had been destroyed. Several B-17 seconds captured intact in France and the Netherlands were repaired and repainted with German markings during the war for deception and training purposes. They were given Luftwaffe serials such as DL plus XC, KH plus BB, and A3 plus AE, operated by Kampfgeschwader 200, the secret Special Missions Unit. These aircraft flew unusual sorties, infiltrating Allied bomber streams to report formations, testing radar reflectivity, and even dropping German commandos behind enemy lines in mock Allied planes. After the war, these rare Luftwaffe fortresses became prized intelligence artifacts. The RAF ferried one example, DL plus XC, to Farnborough for evaluation under the codename Watson's Whizzers. There, British engineers dissected it beside a captured Me-262 jet, two machines that had once faced each other over Europe, now silent exhibits in the same hangar. Today, a handful of photographs survive showing the incongruous sight, a B-17 wearing a black and white Balkenkreuz, the symbol of the very force it was built to destroy. To historians, these images capture a rare moment when the technological rivalry of total war folded in on itself, enemy engineers learning from one another's machines. As the Cold War dawned, Rechlin's role as Germany's test center was quietly resurrected under a different flag. The Soviet occupation zone absorbed much of its infrastructure, and surviving German engineers were pressed into service for both East and West. Some went to the United States under Operation Paperclip, others to France or Britain, and a few to the Soviet Union. Wherever they went, they carried fragments of the same intellectual DNA, the obsession with structural efficiency, the respect for redundancy, and the understanding that no aircraft existed in isolation only within a system. At Boeing in Seattle, designers of the new B-47 and later the B-52 recognized the same principle that the B-17 had once proven under fire. The strength of the network was greater than the sum of its machines. High-altitude bomber doctrine, electronic countermeasures, and long-range navigation all evolved from that same logic of self-sustaining systems. The captured B-17's ghost thus flew again not in aluminum, but in ideas. In the post-war years, veterans and journalists alike retold the story of the Luftwaffe pilots who discovered the downed fortress. Each retelling grew more mythic. Some claimed the Germans had counted not 13 but 15 machine guns. Others said the bomber had continued firing even after its crew was dead, the guns animated by inertia and smoke. These stories, though embellished, reflected a genuine sense of awe. To those who had fought the fortress, it seemed less a plane than a mechanical organism, one that refused to die. German memoirs published in the 1950 seconds and 60 seconds often recalled the encounter as a moment of revelation. One Luftwaffe gunner wrote, "We realized that the Americans built planes the way we built fortresses on the ground, each man protected by the others." In the United States, the myth of the invincible B-17 became part of national identity. It appeared in films like 12 O'Clock High, documentaries, and recruitment posters. The image of a battered yet unbroken bomber, limping home on 3 engines, symbolized endurance, the industrial and moral endurance of a democracy under fire. What the public rarely knew was that even the enemy had admired that resilience, studied it, and, in doing so, unwittingly helped shape the next generation of aircraft that would dominate the skies. Today, visitors to aviation museums in Dayton, Duxford, and Gatto can stand before surviving fragments of that era. A section of fuselage marked with both American stenciling and faint traces of German numbering. The paint is flaking, the rivets dulled, but the paradox endures a weapon built by one nation, tested by its adversary, and remembered by both as an artifact of respect. The B-17's post-war story reminds us that technological progress is rarely one-sided. In war, knowledge crosses boundaries through capture, imitation, or simple curiosity. What began as an act of reverse engineering became, over decades, a shared understanding of how to build machines that survive. The men who once flew and fought those machines grew old under a sky their generation had conquered. When former Luftwaffe test pilot Hans-Werner Lerche visited the United States in the 1960 seconds to meet Boeing engineers, he reportedly walked beneath a B-52 and said quietly, "It is the grandson of the fortress, and I suppose, in a small way, I was one of its teachers." In that moment, the line between enemy and engineer vanished. What remained was the continuity of flight, a lineage born from conflict, tempered by study, and carried forward by memory. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.